we're going to talk about algebraic expressions. Before talking about algebraic expressions, let us start talking about numbers. Well, everything starts with numbers, all right? We have natural numbers. Natural numbers. Starting at 1, then go to 2, then go to 3, go to 4, and so on. But mathematically, we need to have some notations for this. We call it n. We usually use bolded letter n, and we say that n, or the natural number set, is equal to the. We use a bracket or curly braces to represent a set. So n is equal to the set of counting numbers 1, 2, 3, 4, and it continues. Okay. This is natural numbers. It doesn't have any zero in it. I expect you to ask, well, how do I expand this system? We're going to add 0, but we're going to call it a new system, whole numbers. When it comes to whole numbers, we are adding 0. Then we go to 1, we go to 2, 3, 4, and the rest of them. We're going to denote this new set by W. W, or whole number system. This guy is equal to the set including 0, then 1, then 2, then 3, then 4, and the rest of them. So I expect you to ask, well, there are the negative numbers. The negative numbers will be added to whole numbers, and it has a new name. We call them integers. So integers, 0, 1, 2, 3, 4, some positive numbers, and on the left-hand side, smaller numbers, -1, -2, -3, and so on. We're going to denote this set by Z or I. Both of them represent integers. So since we don't have the smallest negative number, we're going to use some dots here. Then comma, -2, comma, -1, comma 0, comma 1, comma 2, and the rest of them. Well, now we don't have any fractions. There are the fractions. We're going to introduce a new system. We're going to call them rationals. Rational numbers. So, well, there are a lot of them. We have a half, we have 1/5, we have 3/7, we have -1/7, we have many fractions. So instead of listing them this way, we're going to use a nicer format, set definition, to represent rationals. We're going to use Q, bolded letter Q, to represent rationals. This is equal to the set of all fractions. Well, fractions are denoted by A/B. Well, what is the condition? So Q is equal to the set of all fractions. The set of all fractions, such that with the condition that we have to impose some conditions. The conditions A and B are integers, but B cannot be 0, and B is never 0. So we introduced a new set, mathematically defined this way. I expect you to ask, there is square root of 2. There is, for example, pi. There is Napier number E. Those are called irrationals. Square root of 2. Square root.
You're saying.
Pi.
You're saying. Sorry.
square root of 2, square root of 5, negative square root of 10, pi, Napier number. These are all called irrational numbers, and you represent them by Q complements. Q, and C on top of it, the complement of Q, or irrational numbers. Okay, then what is R? What is the real line? The real line, or bolded letter R, is the union of Q and QC. You saw this before. This is also represented by parentheses, negative infinity, comma, positive infinity. If I ask you to graph this, to visualize this, we're going to have a line with 0, and then we use some numerical values to scale this line. But this is from negative infinity to positive infinity is your real line. Another representation, bolded letter R, union of Q and QC, or parenthesis, negative infinity, comma, positive infinity. From negative infinity, all of these points are located on the real line. Later on, we're going to take this line and call it x-axis, and then we define y-axis, and then we define the whole plane.